Are you new to 3D printing? Or maybe you've been printing for a while, but just now want to get into creating your own 3D models. You might be asking yourself, where do I even start? Well, there's organic modeling for miniatures, statues, and generally more decorative pieces. And then there is more functional modeling, which includes brackets, cases, frames, and tools. While there are many great tools for organic modeling, like Blender and MeshLab, today we're going to focus on functional modeling. Functional models are generally created with CAD, or computer-aided design programs. These are powerful modeling programs where you design your model as a series of sketches and then extrude them into 3D shapes. Unfortunately, the main CAD programs have steep learning curves, require powerful computers, and are generally very expensive, especially if you plan on selling prints or keeping your design files private. Well, luckily, there's another option. PrusaSlicer!
Wait, modeling in your slicing software?
Well, yes. Today, we're going to design the simple functional model in PrusaSlicer. Now, before you cringe and stop watching, hear me out. PrusaSlicer is capable of creating not only basic shapes like boxes, cylinders, and spheres, but it can also create text, import SVGs, cut models, and even import existing models.
I still don't understand why I'd want to use PrusaSlicer instead of CAD.
Well, maybe you don't know how to use CAD. Most programs do have a very steep learning curve after all. Or they're too expensive. Or your computer isn't powerful enough. Or you're using someone else's computer and your favorite CAD program isn't installed. Or maybe you're creating something very simple, like a standoff, a basic text sign, a minimal bracket, or a simple jig, and using CAD would require opening your CAD program, creating a design, saving it to the cloud, exporting to an STL file, opening it in your slicer, needing to go back to your CAD program to fix dumb mistakes, updating the design in your slicer, and only then actually slicing your model. For something that can be designed in only a few minutes, that sure is a lot of steps. However, if you design the model directly in your slicer, you don't need to worry about the cloud saves, exporting files, bouncing back and forth between programs, and conversion errors. Also, some tasks, like working with text and SVGs, can actually be easier than in some CAD programs. However, while PrusaSlicer can be a great option for quick and simple models, you probably don't want to use it for everything, especially for more complex and challenging models. Why? Because modeling in PrusaSlicer has a lot of limitations. First, unlike in CAD programs, your ability to organize components in a hierarchical fashion is rather limited, and there really isn't any support for joints. Some tasks require a lot of creativity, since you're often pushing PrusaSlicer well past its intended modeling capabilities. Things like fillets and chamfers are possible, but are potentially messy and clunky, especially for non-straight edges. Since PrusaSlicer doesn't support design constraints, parametric modeling, especially with multiple subcomponents, can often be tricky. While PrusaSlicer does have some model measurement capabilities, they are far more restrictive and limiting compared to those in CAD programs. Direct manipulation of meshes also really isn't possible, along with the creation of 2D diagrams for documentation. Design history support is also missing. Finally, and potentially the most limiting, PrusaSlicer is unable to export to STL and OBJ files for many complex models, especially if they contain Boolean operations. Now that we've covered all of that boring background material, let's get to modeling. This is what we will be creating in PrusaSlicer, a cube-shaped box with a lid secured by 4 countersunk screws. Each face of the box, except for the bottom, shows one or more different features available in the slicer, including embossing and debossing with SVGs and text, adding geometric shapes, cutting parts of the model, using other existing models, and even adding basic chamfers. While this model is at the far end of the complexity spectrum of what you would generally want to design in PrusaSlicer, I like this model because it showcases so many features, yet is built up from a collection of individually rather simple steps. Before we dive right in, let's go over the model's major dimensions. Including the lid, the box forms a 50mm cube, with the lid being 3mm thick and the bottom portion being 47mm high. The box will be hollow, except for 4 built-in standoffs, allowing the lid to be screwed on, and holes will be added to the standoffs so M3 threaded inserts can be installed once the model is printed. The lid will have thin alignment guides to help when securing the lid and bottom portion together, and both parts will have chamfered edges. Since the box will be designed for flathead screws, the screw holes in the lid will be countersunk. Now, it's time to fire up the slicer. The first step is to open PrusaSlicer. PrusaSlicer has 3 different interface complexity modes: Simple, Advanced, and Expert. When you first install PrusaSlicer, it defaults to the Simple mode, but since we're going to be using a few of its slightly more advanced features, we need to be in either Advanced or Expert mode. For this video, let's use Advanced. Also, to make some of the required math a little easier, make sure the print bed is at least 250 by 250. I already have the settings configured for the Neptune 3 Max, which has a 430 by 430 bed, so it's more than enough space. Now, as we start, make sure to save often when developing your models, just in case the application crashes or you accidentally change something and an undo isn't working for some reason. We're going to start off by creating the bottom of the box. There are 2 different approaches we could take: creating a box and hollowing out the inside, or creating individual walls. Let's start with the box method. First, right-click on the print bed, click Add Shape, and then Box. This is going to create a cube in the middle of the print bed. Now, before we start shaping the box, we need to disable uniform scaling. When uniform scaling is enabled, all 3 axes, X, Y, and Z, will be scaled by the same amount. While useful when simply scaling up or down an existing model, when creating a model, you generally want to modify each axis individually. Uniform scaling is enabled each time you open PrusaSlicer, so you need to remember to turn it off. Since the complete model we're going to be making is a 50mm cubed box, let's set the X and Y dimensions to 50. The lid is going to be 3mm thick, so the bottom only needs to be 47mm high. To make the math easier, let's move the shape to 100-100 on the print bed. In PrusaSlicer, the reference point for basic shapes is the center of the shape. This means setting the world position to 100-100 moves the center of the shape to 100-100 on the print bed. That's also why the Z position is currently 23.5. PrusaSlicer automatically set the Z position for this shape when we resized it. PrusaSlicer often automatically changes the Z position, so you need to pay attention to it, especially if you don't want it to change for some reason. Now let's hollow out the box. Right-click on the box, select Add Negative Volume, and then Box. Since the walls of the model will be 3mm thick, resize the X and Y dimensions to 44mm. The X and Y dimensions are 44 because we need 3mm on each side, and 50 minus 6 is 44. We now need to set the Z dimension. While we could set the value to 44, PrusaSlicer generally doesn't render the shape properly if a negative surface and positive surface are co-located. PrusaSlicer can also sometimes have slicing and exporting issues if the surfaces are close together. Since nothing will be above the bottom of the box while it is on the print bed, let's set the negative box's Z dimension to 47 to prevent any potential issues. To properly position the negative box, move it to 100-100 in X and Y. If you ever can't see or find a shape, use the object tree on the right to be able to find it. Set the Z position to 26.5 and you should see the negative box appear inside the shape. The Z position is 26.5 because the negative shape is 47 millimeters high, meaning 23.5 millimeters on each side of its center, and the box's bottom wall is 3 millimeters thick. Now let's switch to the preview window to see what the sliced model will look like. This gives us a simple bottom portion of a box. However, there is a problem. Our model needs built-in internal standoffs so the lid can be secured with screws. But we hit a limitation of using negative volumes in PrusaSlicer. Negative volumes remove all positive volume within a shape, so we can't add any additional shapes to inside of the box. For instance, if we add a cylinder to our model and move it to inside of the box, and then check inside the preview window, we can see that the box is still completely hollow. There is a workaround, creating a completely separate object and moving inside of the box. And while this technically works, PrusaSlicer will complain about conflicts in G-code paths. Instead, let's try a different method of hollowing out the box. The first method created a negative volume for one of PrusaSlicer's built-in basic shapes. However, you can also create a negative volume from existing custom models. Let's try this by first switching back to the editor mode, deleting the two cylinders, saving the project, and then closing PrusaSlicer. We now need to create a simple model to act as the negative volume for our box. The model will consist of a 44 millimeter square box with the corners removed to form the standoffs. Let's start by reopening PrusaSlicer and creating a box. Since we just reopened PrusaSlicer, we need to disable uniform scaling again. Now, resize the box to be 44 millimeters in X and 44 millimeters in Y. The height of the shape doesn't really matter, but I found if you set it to about 1 millimeter or less, PrusaSlicer has a tendency to hang, so let's set it to 2 millimeters. And then we can move the shape to 100-100. Create a negative volume cylinder to form the first corner. While not really required for a model this simple, it's a good practice to rename the various shapes and subshapes in your model. Let's rename the entire shape to hollow, the positive box to base, and the negative cylinder to corner 1. We can now resize corner 1 to be 7 millimeters in X, 7 millimeters in Y, and 2 millimeters in Z. Then we can move it to its corner position of 80-80. In this situation, PrusaSlicer doesn't automatically adjust the Z position, so we need to manually set it to 1. To create the remaining 3 corners, let's copy corner 1 and then paste it 3 times. Now let's rename the copies to corner 2, corner 3, and corner 4. Let's now set the Y position of corner 2 to 120, the X position of corner 3 to 120, and the X and Y positions of corner 4 to 120. Now we can verify what the model looks like in the preview window. Since the model looks as expected, we can save the project. Since we already renamed the entire shape, the file name is already correct. While saving the project is always a good idea in case you need to make changes later, we also need to export the model to an OBJ file. This is because if we try to use the 3MF file as our negative volume, the 4 corners would be lost, as PrusaSlicer doesn't seem to support negative volumes within other negative volumes. So we come up, we hit export, export plate as STL OBJ. We change the file extension to OBJ. We hit enter and it'll start exporting. The exporting process occasionally takes a little bit of time. Now that the model has been exported, we can close PrusaSlicer. Let's now reopen PrusaSlicer one last time and open our demo project. And don't forget to disable uniform scaling. We now need to delete the negative volume from our first attempt. To add the hollow model we previously created, right-click on the box, select Add Negative Volume, Load, and then the hollow object file we previously created. We now need to resize and reposition the negative volume to the same values as the previous volume we just deleted, which is 44 millimeters in X, 44 millimeters in Y, 47 millimeters in Z, and then reposition to 100, 100, 26.5. The model should now be ready, so let's verify in the preview window. We can see that the box is again hollow, but now we have 4 built-in standoffs, exactly what we need. It's also possible to create the bottom of the box without using negative volumes. Instead of creating a solid block and then removing material, we can create each of the sides and standoffs individually. Let's try this approach. First, delete the entire previous shape. Then, create a box which will form the bottom of the shape. We have to resize this to 50 millimeters by 50 by 3 and reposition to 100, 100. We could create the rest of the walls as subshapes using the Add Part feature, but that could be a little annoying because PrusaSlicer often changes the height of shapes when positive subshapes are resized. To avoid this, we're going to create the other walls as separate shapes and then merge them. Let's start with the front wall. So create another box and resize it to 50, 3, 47, and reposition it to 100, 76.5. We can create the back by copying the front wall and moving it to 100, 123.5. Let's add another box to form the left wall. We have to resize this wall to 3, 50, 47 and move it to 76.5, 100. Create a copy for the right wall and position that at 123.5, 100. Now that we have all 5 walls, select all of them by holding down the Shift key and clicking on each shape. With all of the walls selected, right-click on one of them and select Merge. We can now rename the walls. Let's rename the bottom to bottom. We have front, we have back, we have left, and we have right. We could rename the entire shape, but because we have to merge in the cylinders, the name is going to get automatically changed, so we'll set that at the end. Now we need to add the standoffs. So create a new cylinder, resize it to 7, 7, 47, and position it at 80, 80. We can now merge that into the main shape and rename it to standoff 1. Let's now create 3 copies and rename them to standoff 2, standoff 3, and standoff 4. We then need to change the Y position of standoff 2 to 120, the X position of standoff 3 to 120, and the standoff 4 position of X and Y both to 120. Now that all the parts are together, let's rename the shape to bottom. The main part of our bottom should now be complete, so let's look at it in the preview window to see what it looks like. The model looks the same as in our previous method, where we have a cube, it's hollow, and we have our 4 built-in standoffs, so it looks exactly as expected and what we were looking for. So let's save the file. We now need to add holes so M3 threaded inserts can be installed in the bottom of the box, as these will be used to securely attach the lid once everything has been printed and assembled. When designing holes for threaded inserts, you want the diameter to be slightly smaller than the outer diameter of the insert. The inserts we will be using today have an outer diameter of 4.6 millimeters. I like to design my holes about 0.4 millimeters smaller. That means we need to add holes with a diameter of 4.2 millimeters. The length of the hole is also important, since there needs to be enough room for both the insert and any portion of the screw that extends past the end. Let's design for 8 millimeter screws, and since the lid is 3 millimeters thick, our hole should be about 6 millimeters deep. That allows for the screw to extend up to 2 millimeters past the end of our 4 millimeter long threaded inserts. Let's start by creating a negative cylinder and renaming it to Insert 1. We can then resize it to 4.2 by 4.2 by 6 and positioning it at 79.5, 79.5, and 44.5, which will put it right at the top of the bottom of the box. We then need to create 3 more insert holes. So let's copy and paste, and let's rename them to Insert 2, Insert 3, and Insert 4, and then we can change the Y position of Insert 2 to 120.5, the X position of Insert 3 to 120.5, and both the X and Y position of Insert 4 to 120.5. Now that we have our insert holes, let's see how they look in the preview window. So now we have our model, and there's these nice holes where inserts can be installed. While the final version of the box bottom will have decorations and a few modifications, let's design the lid now so we have everything we would need for a basic project enclosure. Let's start by creating a new top level box and resizing it to 50 millimeters by 50 millimeters by 3 millimeters and positioning it at 200, 200. The location is arbitrary, but it'll make the math a little easier. We don't need to set the Z position, since PrusaSlicer already did it for us. We now need to add clearance holes so the screws can go through the lid and into the threaded inserts in the bottom of the box. A common diameter for M3 clearance holes is 3.4 millimeters, which gives a little bit of forgiveness if the holes are not perfect, but are also not large enough for the lid to really wiggle. The clearance holes will completely go through the lid. Let's start by creating a negative cylinder and then renaming to Clearance 1. We can also rename the top level shape to lid and the positive box to base. Let's now resize the clearance hole to 3.4, 3.4, 3, and move it to 179.5, 179.5, and 1.5. We can now create 3 more clearance holes by using copy and paste. Let's rename to Clearance 2, Clearance 3, and Clearance 4, and moving the Y position of Clearance 2 to 220.5, the X position of Clearance 3 to 220.5, and the X and Y position of Clearance 4 to 220.5. Now that all 4 of the clearance holes are in position, let's take a look in the preview window. And we can see we have our holes and they go straight through the lid. While simple clearance holes are fine for many applications, especially if you're using socket head, pan head, or button head screws, they do leave the screw head raised above the surface of the model. One simple solution is to use a counter bore so the screw head is recessed. While simple to model, counter bores do have a drawback. They require your lid to be thicker than the screw head. The head of an M3 socket head screw is about 3 millimeters, and our lid is only 3 millimeters thick. So counter bores really are not an option for this model. However, just for the practice, let's create some, pretending the screw heads are only 1.5 millimeters thick. Let's start by creating a negative cylinder, renaming to counter bore 1, and then resizing to 5.5, 5.5, 1.5, and then repositioning to 179.5, 179.5, and 2.25. We can then create the remaining 3 counter bores by using copy and paste, renaming to counter bore 2, counter bore 3, and counter bore 4. Now we need to change the Y position of counter bore 2 to 220.5, the X position of counter bore 3 to 220.5, and the X and Y position of counter bore 4 to 220.5, 220.5. We can now look at the model in the preview window. And we can see that we have our 4 counter bores. We have the spot where the head would rest, and our model looks correct. However, since we are not using counter bores in this model, let's delete these. Instead of socket head screws and counter bores, we're going to use countersunk flathead screws so the screw heads are flush with the surface of the lid. While modeling a countersink involves more math than a counter bore, they are still rather easy to create with only features built into PrusaSlicer. When hollowing out the bottom of the box, one of the approaches we took was to create a negative volume using a custom model. Well, PrusaSlicer includes a gallery of built-in shapes, and one of them is a cone, which you can use to form the countersink. The head of the screws that we are using have a 90-degree taper, which implies the diameter of the head is twice the height of the cone portion of the screw, assuming it's a perfect triangle in 2D or cone in 3D. To find the correct diameter for the cone, I created a simple tester, modeled and sliced completely in PrusaSlicer. Using the tester, 6.2 millimeters allowed the screw head to sit perfectly flush, but only if the hole was printed perfectly. Assuming 3D printed holes will have some imperfections, 6.8 millimeters seemed to provide enough forgiveness for the screw head to sit flush even when they were printing imperfections. Using a 6.8 millimeter diameter, the cross-section of our countersink will look like the following. To create a countersink, right-click on the lid, go to Add Negative Volume, Gallery, and then select cone.stl. We can then rename it countersink 1, and then we have to rotate it 180 degrees around the x-axis so it is pointing down. We can then resize it to 6.8, 6.8, and 3.4 and position it at 179.5, 179.5, and 1.3. To create the remaining 3 countersinks, we can use copy and paste and rename to countersink 2, countersink 3, and countersink 4, and then change the countersink 2 Y position to 220.5, the countersink 3 X position to 220.5, and then both X and Y of countersink 4 to 220.5. That should form all 4 of the countersinks, so let's take a look in the preview window. We can see the countersink taper formed by the cone and then the vertical portion formed by the cylinder. Since everything looks correct, let's save the project. These are all of the steps required to model a basic project enclosure. However, let's keep going and add some decorations and other features. Let's add some raised text to the lid. Start by right-clicking on the lid, going to Add Part, and Text. I'm going to change the text to S&M Makers. Now let's change the style to Swiss. And I'm going to change the font to Verdana. Now let's change the name so that it's a little easier to find. And now we need to set the dimensions. Let's make X about 35. And then let's have it raised up about 0.5 millimeter above the surface of the lid. We now need to move it into position. Let's go at 200 so it's centered, and move it up a little bit at 210. Unlike with basic shapes, the reference point for the text is the bottom, not the center. So we need to keep the Z position at 3, which is the top of the lid. Let's add some sunken text to the lid. So right-click on the lid, go to Add Negative Volume, and Text. Let's change the text to Demo, and then let's change the font to Arial Black. Okay, let's now rename it so it's a little easier to find. And the dimensions, they look fine for this, so let's keep those the same, but we need to position it, so let's center at 200, and then let's move it down slightly to 190. So that should complete our text. Let's look at it in the preview window, and you can see that we have our raised S&M Makers text, and we have our sunken demo text. Since everything looks correct, let's save the project, and we can move on to the next step. Let's return to the bottom of the box and add a raised SVG to the front. So right-click on the box, go to Add Part, and SVG. I'm going to use an SVG file that I already have, and let's resize it so it's got a height and width of 35 millimeters. And let's set it so that it sticks out of the box by 0.5 millimeter. We now need to position it. Let's make it centered on the front of the box if the lid is installed. So we go with 100, 75, and 25. And that gives us a raised SVG image in our model. Let's now add a recessed SVG image to the right side of the box. So we right-click on the box, we go to Add Negative Volume, SVG, and select an SVG image. Let's make this image the same 35 millimeter square as the previous. And let's have it be recessed 0.5 millimeter into the box. And now we just need to position it at 125, 100, and 25. Now that we've positioned the SVG, let's see how it looks in the preview window. And we can see that we have our positive SVG image and we have our negative or recessed SVG image. So now let's just save our project, and we're ready for the next step. We can add more than just text and SVG images to our model. For instance, we can add a built-in shape from the gallery. Let's try this by adding a torus shape to the back of the box. So we right-click on the box, we go to Add Part, Gallery, and then we select our shape. Since this is a positive subpart, we're going to temporarily move it to 50 in the Z-axis, so resizing the torus doesn't move the entire model. Also, so it's orientated correctly, we need to rotate it 90 degrees along the X-axis. Now we have to resize it. Let's go with 25, 3, 25, and we have to position it so it's right up against the face of the box. So we'll go with 100, 125, and 25. Now let's make the torus a little more interesting by putting a hole in the middle. So we're going to right click, go to negative volume, and add a cylinder. So it's easier to figure out what part is what, let's rename this the torus port. And just like with the torus, we have to rotate it 90 degrees along X. And we can resize it so that the outer diameter of the cylinder matches the inner diameter of the torus. So we'll go 15, 5, and 15. And then we just have to position it at 100, 123.5, and 25. So that should put it right in the middle, and we can check it in the preview window. And we can see that we have our torus shape and we have a nice hole right in the middle. Let's go back to the modeling window and save our project. Since we still have one more blank face on our box, let's use a custom model to cut out a shape in the box's right wall. So let's right click on the shape, go to add negative volume, and then load. Now let's select a custom U-shape model I previously created in PrusaSlicer, making sure to select the object file, not the 3MF file. To get the shape into the correct orientation, we need to rotate 90 degrees around Z and negative 90 degrees around Y. Now we can move it to the correct position. So we'll move it to 77.5, 100, and 25. So that should put it right in the middle. And let's look in the preview. And we have a nice cutout based off of our model. So now let's go back to the editor window and save our project. With our decorations complete, it's time to add chamfers to the side edges of the box. While PrusaSlicer doesn't directly have a chamfer ability, we can still get the same effect along straight edges by using negative volumes. Let's start by creating a negative box, and then let's rename it to corner 1. We then need to resize it to 4, 4, 47, and then we have to rotate it 45 degrees around the Z-axis. It's important to resize the volume before rotating, or the math becomes a little more complicated. And now we can move it into its final position of 75, 75, and 23.5. Now we need to create the other 3 corners, so we'll use copy and paste. And again, we will rename to corner 2, corner 3, and corner 4. And we'll change the Y position to 125, the X position to 125, and the X and Y position to 125. Now let's see what we have in the preview window. And we can see we now have some nice chamfers, so the sharp edge is removed from the box. So let's go back to the edit window and save the project. We now need to add chamfers to the lid, and the process is almost identical. We start by right-clicking and going to negative volume and creating a box, and let's again rename it to corner 1. We can then resize to 4, 4, and this time 3 millimeters. And again, we have to rotate 45 degrees around the Z-axis. And we can move it to its final position at 175, 175, and 1.5. And now we need to create the remaining 3 corners using copy and paste. we need to rename to corner 2, corner 3, and corner 4, and reposition, changing the Y to 225, changing the X to 225, and changing the X and Y to 225. Now with all the volumes in place, let's see what it looks like in the preview window. And we can see, just like with the bottom of the box, we have some nice chamfers on our lid. So let's go back to the editor window and save our project. With the chamfers in place, we reached the final step in creating our model, adding alignment guides to the lid. These small guides are fairly standard in project enclosures and help align the lid to the bottom of the box. Start by creating a positive box and renaming to Guide 1. We need to resize to 30 millimeters by 1 by 2 millimeters, and then moving it to 200, 178.6, and -1. Ignore the warning for right now. Now let's create 2 more copies, renaming to Guide 2 and to Guide 3, and moving Guide 2 to 221.4 in the y-axis. But for Guide 3, we first need to rotate by 90 degrees around Z. And now we can move to 178.6 and to 200. To create the 4th guide, let's create a copy of 3, rename to Guide 4, and move it to 221.4. Now that we have our guides in place, however, there's a slight problem. Our guides are below the surface of the bed. So to fix that, we're going to select the entire object and then click this little syncing icon, and it's going to raise the entire lid up so the bottom of the guides are at the top of the print bed. So this completes creating our model. So let's see what we have one last time in the preview window. So we can see we have our box, we have our 4 decorations on our 4 sides, and we have our lid where we have our 2 types of text, we have our countersunk holes, and we have our alignment guides. So our model is now complete. Let's go back to the editor window and save our project one last time. That concludes our adventure into modeling with PrusaSlicer. The model we created is on the far end of the complexity spectrum for models that you would want to create in PrusaSlicer, but I hope we gave you a solid understanding of what is possible. While the model is a bit complicated, it's built up from a number of relatively simple steps that you can mix and match in your own designs. Well, that's it for now. Don't forget to subscribe to our channel, and if you want to be a super supporter of us or Bed Leveler 5000, come visit us over at Patreon. Thanks for watching.